Hello, we are taking a look at lesson 7.2. Hope your day's going well whenever you're watching this, and I hope you're ready to learn a little something. We're looking at lesson 7.2, central and inscribed angles, okay? So we're talking about the angles inside of a circle. Let's read the first blurb here. We got this picture of this circle with some points, D, C, E, and F. What are DC and DF? Some review from our vocab. Those guys are radii. Right? Radiuses, right? But technically we call it radii. That make the angle DC and FC. DC and FC. They combine to make this angle right here. They make the angle DCF. Or you could call it angle FCD, whichever your heart desires. The vertex of this angle is at the center of the circle, right? The vertex, if you don't recall that word, is where the arms sprout from, right? They're sprouting out of point C, and point C happens to be the center of the circle, and it is therefore referred to as a central angle. Makes a lot of sense, right? The vertex is at the center. We call it a central angle. The intercepted arc, intercepted being like a fancy word for where it intersects, right? Where it touches, right? When this angle opens up, we're intercepting the arc D to F. You see that? When the arms sprout out, they connect with the circle and form this arc DF. Okay? So, what do we know about central angles? We know that the angle is equal to the measure of the arc. Okay? Because we measure arcs with degrees and we measure angles with degrees. So we can go 360 degrees all the way around a circle, and our angle can open up and be anywhere from 0 to 360 degrees. They match, okay? So the measure of the angle is equal to the measure of the arc, all right? So let's solve. We know that angle DAC is 40 degrees. So if we know the angle is 40 degrees, then I immediately know that this arc is 40 degrees because the measure of the central angle and the arc are the same, okay? And angle FAB is 110 degrees. So if this is 110 degrees, then I know the measure of this arc is 110 degrees. So it's our job to determine the rest. Well, you need to make some keen observations here that FC and EB are diameters, right? FC and EB are diameters. And that's pretty important because that means we know that this is 180 degrees from E to B. So if that's a total of 110, that means that this smaller portion right here has to be 70. So that way it adds up to 180, 70, and 110. Okay? And this right here is a diameter. So we know that this is 180 degrees. 70 and 40 add up to be 110 degrees. So wait a minute, that means this has to be 70, because 70 plus 70 is 140, plus 40 gives us a total of 180. And then last but not least, again, this is a diameter, so we know that this is 180 degrees. So if this is 110, well then that one has to be 70 degrees. Crazy, right? Notice I completely ignored all of these. I've mentioned this before in the past. When it comes to like solving for things, I think it's better to use the picture and just solve for stuff that you know than it is to like focus in like in depth on one specific thing, because you might get stuck, right? Just use the picture and solve for what you can and then go from there. You know what I'm saying? So arc EFD, E to F to D. Holy cow, that's nearly all the way around. So basically just add all of these together. Or you could think, well, this is a full 360. I'm going to subtract away the 70, so that way I'm left with what I want, right? Does that logic make sense to you? So this is going to come out to be 290. The measure of arc DC. The measure of arc DC, well, I already did that. That's 40. The measure of arc FAE. Angle, sorry, FAE. The measure of angle FAE. Well, using the logic that we said over here, right, that angles are equal to the arc, well, now that we know the arc, we can determine the angle. It is also 70 degrees. All right, I've been solving a lot of these for you. Let's introduce some questions here. Let's have back-to-back-to-back questions for these three things. Some of it I might have already written down. Some of it I might not have. We're winging this together, right? So take a look at these three, and the back-to-back questions are coming up on screen. All right, so the questions went up. FB I already gave to you, 110 degrees. FBD, okay, let's make sure you did your addition correct. F to B to D. Well, I know that this is 180, and then 180 plus 40 gives me 220. And then E angle EAD. Well, because we already know this arc is 70, that means that I immediately know that this angle is 70. So hopefully you got those right. So what's the big idea here? Central angles are angles that have a vertex at the center. All of these angles in the center are central angles. By the way, this is 70 as well, right? And when those angles open up, they end up touching the circle, and the measure of the arc is the exact same as the angle. That's the big idea there. Pretty straightforward, right? Okay, same picture, except now we're talking about DE and FE. What are these called? DE and FE are chords. They're not diameters because they're not going through the center. They're chords that make the angle DEF, or you could call it angle FED. The vertex of this angle is at the, more like on the edge, right? It's on the edge of the circle. And it is referred to as an inscribed angle. Inscribed angle. The intercepted arc is that guy right there. The angle opens up. It still touches the same arc. I want you to realize that, right? This angle and this angle create the same arc, okay? This angle and this angle create the same arc, DF. That's a pretty big deal. That's a pretty big observation. But what is the relationship that occurs here? The angle is half the arc. The angle is half of the arc. So where here the arc and the angle are the same because it was a central angle, now it's half. Okay, this is a smaller angle. And take a look at this picture. I think you can agree, right? This angle is narrower than this angle, right? That's much wider. It's double the size, okay? So we're taking half the arc. So let's check this out. If we know that this arc is 140, take half. Oh, it's that easy. It really is that easy. 70 degrees. Boom. If we know that this angle is 80, well then we double it to find the arc. Boom. 160. It really is that quick. And what's the difference between these angles and the ones above? The vertex is on the edge. The vertex is on the edge, making them inscribed. So it's telling us that this is a diameter, so we know that that's perfectly cutting the thing in half, okay? And we'd like to figure out the measure of these arcs. Well, let's take a look. Measure of the arc BC. Well, it's all about observation here of how is this arc being created? How is this arc being created? Well, it's being created, so to speak, by this angle. You see how that angle that I'm drawing over the top of is opening up and creating this arc, right? Well, that angle is 31 degrees. So double it and you get the size of the arc, 62. Because this angle is inscribed. That vertex is on the edge. You see that? It's on the edge of the circle. What about the measure of the arc BD? Well, B to D is a combination of BC and CD. They told us CD. So BD is a combination of the two. That's 62 plus 88 is 150. Okay, now we want angle DAB. I know I'm doing all of these, but honestly, I think the visualization is a little more difficult for these, so I just want you to see them as opposed to stressing, okay? This is also, back up a step, erase my lines, right? I could have asked at the start, well, how many angles are here? There's 1, there's 2, there's 3, right? 3 inscribed angles. Do you need to see them again? Do you need to see them again? Let me do different colors, right? There's this angle. There's this angle. And then there's the two of them combined to make a big angle, right? They're all inscribed because each one of them has a vertex at A, okay? That's not changing. So if this is 62 and this is 88, well, this big arc is created by this big orange angle that I drew. And that is angle DAB. So if this totals 150, take half of it to find the angle 75 degrees. And if the whole thing is 75 and this piece is 31, then how big is the other piece? One's ABC. Oh, interesting. Is that a typo? Can we find that? I was about to answer what the size of this angle was right here. By the way, what is the size of that? That is 40 or 54. Or no, 44, sorry. Wait, did I add 62 and 88 wrong? $150 divided by 2, 75. I'm going to pause for a second. I feel like I made a mistake. Okay, I didn't make a mistake. Yeah, I just was getting confused on my calculator there. This is 44, right? Half of 88 is 44. But also, I want you to do a double triple check. 31 plus 44 is 75. That's the whole thing, right? But if you multiply that by 2, you get 150, right? It all comes together, right? And this big arc is 150. Now, it asked us to solve for ABC. and I'm realizing that that's not a typo. That is honestly that's a pretty advanced level observation here. Let's erase all of this because it's getting messy, right? I'm sure you can agree it's getting a little messy. ABC, A to B to C, that's an angle, and it's intercepting this big arc. Oh, let me draw that a little cleaner. This big arc, right? And how big is that arc? It's a perfect 180. It's half the circle. So this angle intercepts this arc. That's actually a perfect right angle. Can you believe that? Right? That is actually a right angle because half of 180 is 90. So this is a right triangle within our circle, just hiding amongst the weeds. Does that make sense? You see how I drew that out? This vertex is on the edge of the circle. It fits the definition of an inscribed angle, and it matches up to this perfect semicircle. All right, let's bust through a couple more examples. These are pretty quick, and I bet we're going to end right at the 20-minute mark. So this is just doing some algebra, right? Answer this for me real quick. Is this a central or inscribed angle? You should have said central, and central angles are equal to the arc. So if we solve this, 5x minus 10 is equal to the arc of 140. Add the 10, you get 150. Divide the 5, you get 30. X is 30. Here's another question. Is this a central or inscribed angle? You should have said inscribed. And inscribed is equal to half the arc. You want to try to solve that real quick? Try to set up that equation and try to solve it. Why don't you give that a look-sees and try to solve that equation. All right, so hopefully you gave that a shot. This angle is equal to half of this, right? How do you take half of that? Well, just divide it by 2. Just instead of writing it like all fancy like that, how about I just divide it by 2 like that, right? Does that make sense? I want to keep this highlighted. Does that make sense? So when I take half, I'm going to end up with 9x minus 24. Subtract the 7x. I'm going to get negative 16 equals 2x minus 24. Add the 24 over. I get 2x equals 8. X equals, not 2, 4. And there's that. This is a little bit random, but not quite random. Inscribed quadrilateral theorem. So the idea of being inscribed is the fact that the vertices are touching the circle. Okay? So instead of it just being a single angle, instead of it just being one angle that's inscribed, we're actually turning it into a quadrilateral. Okay? So boom, 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 boom. So that's kind of like a rectangle. It's not a perfect, it's not actually a rectangle. It's just 4 sides. It's almost a rectangle, but not quite. This inscribed quadrilateral, we'll say it's RSTU. Okay. If the measure of angle R equals 74 degrees, and the measure of angle U is 103 degrees, then find S and T. Well, this is true right here. The opposite angles of any inscribed quadrilateral are supplementary. Do you remember what that word means? adds to 180 degrees. Okay? When you have an inscribed quadrilateral like this, inscribed meaning the vertices are touching the edge, the opposite angles are supplementary. So this S is opposite of R. Okay? It's opposite of angle R. Therefore, 74 plus angle S should equal 180 because the opposite angles are supplementary. So subtract the 74 and you end up with 106. So can you find angle T for me real quick? Sorry, I went over 20 minutes. We're almost done. Can you find angle T for me real quick? It's opposite of U. All right, so you answered it. It's 77 degrees because 103 plus 77 is 180. I'll do this super quick here. Stay with me. 2x minus x. Sorry. These are opposite. Let me set it up. These are opposite angles. They should add together to be 180. And these are opposite angles. They should add together to be 180. That is, if you have an inscribed quadrilateral, it's just a fact. The opposite angles add together to be 180. You can safely assume that, okay? So this is 3x minus 9. Add the 9 over, you get 189, and divide by 3, you get 63. Add the 5 and the 75 together, you get 180. Subtract the 80, you get 100. Divide the 3, it ends up coming out to be a fraction. All right, there's that. I appreciate you watching. I hope you have a good rest of your day, and I'll see you in class. Yeah, have a good one.